So I'm working back on the Wren computer. I have 3 of these to repair, and I'd got as far as getting them all to boot to the welcome screen. I've got one booting from a floppy disk, and the other 2 I needed to get replacement floppy drive controller ICs for. So they've now finally turned up. So what I'll do is I'll get this failed device swapped out. Before I can start testing the floppy drive, however, I need to calibrate the replacement for this particular board. So whenever you replace these devices, they need to be calibrated to the particular board that you're fitting them to. That's what this pot is for here. You can see that when they made this machine, they adjusted the pot and then put some gunk on it to stop the pot moving. Before I scrape that off, I'll actually put the replacement device in and see if we do need to adjust the pot. If we don't, and I'll leave it, but I'll get set up to calibrate the replacement device, and we'll go from there, see if we can calibrate it, and then we'll start testing the rest of the interface for the floppy disk. Okay, I've got the system set up ready to calibrate the floppy drive controller chip. I've got a test clip on the device. I've attached a couple of jumpers. The white jumper is connected to the master reset line of the floppy drive controller. If we look at the spec sheet, you can see pin 19 is master reset, and the red jumper is connected to pin 22. And if we look at the spec sheet, you can see that pin 22 is the test pin. And I've got the scope connected to pin 29. And pin 29 is the TG43 pin, which in the test mode is used as the test output. So what we have to do to put the device into calibration mode or test mode is to ground the test pin and then strobe the reset line. So I'll power up the Wren and get it running. And you probably can't see it, but the power LED has come on a solid light to indicate the self-test has been successfully passed. And if I just move the camera, you can see that the Wren has successfully booted, or at least to the welcome screen. So what I have to do now is to ground the test pin and then strobe the reset line. So we're looking for 2 things here. We're looking for a series of pulses on the scope at a frequency of 250 kilohertz, and we are looking for a pulse width for those pulses of 450 nanoseconds. So I'll strobe the reset pin, adjust the scope, and you probably can't see it, but it's saying 249.9 kilohertz, which is fine. So to adjust the pulse width, we'll just see what it currently is. So it's about 680 nanoseconds, so it does need to be adjusted. So I'll just get the gunk off the pot, and then we'll try to adjust that pulse width. Okay, I've got the gunk off the pot, and what I'll do now, rather than adjust the pot and keep tweaking the scope, I'll just set the scope so it's already set to 450 nanoseconds, and then we can just adjust the pot until the scope indicates that we're at the right pulse width. So the markers on the scope are now set to 450 nanoseconds. I'll see if the pot can adjust the pulse width to give us the correct value. Which it does, so that's fine. So that's 450 nanoseconds, and we can now remove the jumper from the test pin, and the device should return back to normal. And I'll reset the Wren, and it should come back to life. And again, it's successfully completed the self-test. The welcome screen has come back on, and what I want to do now is move the scope to the raw data pin, and I'll now power the floppy drives are currently on a separate power supply, so I'll get those powered up. Okay, the two drives do have issues that I know about. They do need adjusting, but if I just change the gain of the amplifier, or the threshold of the amplifier, you'll see on the scope that we can go from just a noisy reading to nothing. Adjust the scope time base a bit there. So in general, the starting point for this adjustment is to just start going into where you're seeing noise. The drives are dynamic. The signal you get from them is dependent on the disk motion, so you will get a bit of noise on them when the disk isn't there or not spinning. Now, we do have an issue still with this, in that the Wren is not at all happy with these powered up. I'll just move you across so you can see the screen. So as you can see, it's not happy with that device in there. It wasn't doing this with the original device. Now, it is possible these devices are faulty. This is one of the issues we quite often encounter with vintage equipment, or it could be there's a failed chip or two in the floppy drive interface. So what I'll start doing now is investigating the floppy drive interface, see what's going on, try and figure out why the Wren's doing this. Haven't ever seen this before, so this is kind of a new one. Yeah, it's quite an interesting one. See if this has anything to do with this new floppy drive controller, and trying to get the system to read the floppy disk. Okay, well, after a bit of investigation, I found a couple of failed tracks. The circuit underneath where the battery sits is responsible for generating various clocks and timing control signals, so it kind of choreographs what's going on different parts of the board. And what was happening here is the floppy drive controller chip was successfully reading a data byte, but because of the way the fault manifested itself, it was then causing the data byte being read from the floppy drive controller to end up in the wrong place on the board, in effect. So what was happening was the CPU was being told there was floppy data available, but when it tried to read it, two of the bits weren't available and it was reading garbage, and it was doing something peculiar and jumping off into a weird bit of code, which is why we saw the disruption on the Wren display. I fixed that. I've been through and using the scope, we seem to be getting data now coming from the floppy drive controller, in as much as pin 38 is toggling, which is the data ready pin. I can't find any other faults in this area of the board, so in theory, unless there's something else wrong with other parts of the machine that's going to hamper the floppy drive reading, the system should now be able to read the floppy disk. Now, there's no guarantee it will boot, but we should be able to see either the floppy drive being accessed or possibly an error message on the Wren screen. So I'll boot up the machine again, and we'll see if it's got rid of this weird behavior we were seeing before. Okay, so the Wren has successfully booted. Again, you probably can't see the LED, and I'll just move the camera across so you can see the screen. and you can see it's now come back to the welcome screen. So what I'll do now, I'll move the camera back. Unfortunately it's very difficult getting everything in at the same time. I'll put the floppy, the OS disk into the floppy drive and see if it attempts to start reading it. Now it should at least spin up the drive, and if we made any progress then hopefully it will start trying to read sectors. Now it might crash, it could do anything, but I want to see if the floppy drive controller at least tries to drive the floppy drive. With the old controller it was doing nothing at all. Okay, so we'll put the disk into the drive. So putting it into the top drive here. Let's move the camera across so you can see. And it is indeed reading sector, so I'll just move the camera back so you can see the screen. And that's a good sign. And we have a booting machine. I have no idea if this will work yet, so I'll try pressing F5. I'll move the camera across so you can see more of the screen, and then I'll press the F5 key, and that should take us into CPM if the machine is capable of booting to that degree. And it has indeed booted into CPM. Okay, looks like we have an issue with the keyboard. It's not reading all the keys. Or possibly the system's crashed. What may have happened is if the system's not fully functional, then it may have gone through partly loading CPM and then hung, so I need to investigate this further. What I'll start off by doing is removing the disk, and I'll reset the Wren. I'll put the disk back in and see if the machine can reboot. And it is reading the disk. Okay, so I'll try a different key this time to see if we can navigate around the menu. Okay, so it's not working properly. I think some of the keys aren't working, or there's something wrong with another part of the machine, but we have got as far as getting it to boot, and once we get this far then it starts to get a bit more straightforward because we've got more functional system to actually look at, and of course we can start running some more meaningful tests. So that's it for this video. It looks like we're getting a lot further with this machine. The new floppy drive controller device seems to have worked. It calibrated successfully, and we can now read data from the floppy disk. In the next video I'll go through and see if we can figure out why the keyboard is not working properly. Might just be something to do with the keyboard controller, so hopefully it's something fairly straightforward. I do have a spare keyboard I can try, so I'll just swap that out and see if the keyboard itself is faulty. But once we've got that sorted out, then we can start looking at some final tests and then investigate the software that comes with the machine. And that will then just leave one more machine to sort out, which I think has a failed floppy drive controller chip as well. Once I've done that, I've got one floppy, or at least one floppy drive to repair, but I'll do that in a separate video. As ever, comments are welcome.